Hi, thank you for the opportunity to allow us to present today. My name is Andy. Really excited to be here with the team of Douglas, Raul, Farzad, and Swapna. We're a team known as Highway 51 Revisited, and over the last 10 weeks, we've put together a very exciting project that looks at the infrastructure, charging infrastructure for electric vehicles. And in particular, we teamed up with Chevrolet to analyze data and present some results and recommendations for how to best position Chevrolet in the electric vehicle market in the future. Our presentation today is going to consist of, first I'll introduce the team, and then I will turn it over to Douglas, who's going to go through problem statement, goals and methods that we employed, and what data sources we use. He's also going to cover some demographic trends. We'll then have Raul look at some customer segmentation. Swapna is going to cover our modeling approach. And Farzad is going to wrap up with web and mobile app demonstration for you. With all that presented, we'll have some final recommendations that I will present at the very end of this session. So with that being said, give a little deeper dive into our team itself. I'm the product owner. I've had experience in the renewables market and mostly on the installation of infrastructure in renewables. Very passionate about the electric vehicle market. Super excited to actually have an opportunity to work on a project like this. Joining me is Douglas. He is our operations research analyst. He really delved deep into the data, and you'll see some really fantastic results that he noticed by looking through and doing our exploration of the electric vehicle market. Farzad is our data engineer. He actually is built our web app, made that thing hum, and is really got some exciting stuff to present for you. Swapna is our data scientist. She presented or put together some fantastic models, and Raul is our solutions engineer, and he actually did some excellent exploratory data analysis and segmentation work. So that's our team. Next, I'm going to turn it over to Douglas to cover the background and hypothesis. Douglas?
Yeah, thanks, Andy. So General Motors, of course, is one of the big three US auto manufacturers, and then Chevrolet is a subdivision within the General Motors company. Our project has really sprung from three interrelated facts about General Motors and the current EV marketplace. So the first of those is that in their 2021 Q2 financial report, General Motors declared their intent to achieve #1 market share in the North American EV marketplace. Now, they didn't identify a timeline that they were planning to achieve that goal on, but regardless of timeline, that really represents kind of a pretty steep hill for GM to climb, because Tesla Motors currently accounts for 72% of the marketplace. And the only all-electric vehicle that General Motors makes is the Chevy Bolt, which currently only accounts for about 11% of that same market. So the question really is, how does Chevy get from here to there? And when we asked that question, there are two additional facts that really stood out initially as potentially significant. The first is that the Chevy Bolt has a starting price that's $6,000 less than the Tesla Model 3, which is the Tesla model that it shares a vehicle class with. And then second is that the infrastructure bill that was pending at the start of this class and that has since passed sets aside $7.5 billion for expanding EV charging infrastructure into disadvantaged and underserved areas. So all of that's kind of led us to a hypothesis that Chevy, although their current market share is small, might actually be really well positioned to expand that market share, since they have an established vehicle that's relatively low cost, and that might be a nice fit to surge into some of these underserved and disadvantaged areas that are about to see this influx of new charging infrastructure. Next slide, please. So before going any further, I want to talk really briefly about charging infrastructure and why we thought it might demand a closer look, because this is still kind of new to a lot of people. I definitely wasn't familiar with it before beginning work on this project. EVs have 3 different levels of charging that they can charge at. So higher levels are faster, and that matters, especially when you're traveling long distances, because nobody wants to spend like a day and a half at a filling station. Higher level charging also tends to be less standardized and more proprietary. So everybody can charge at a level 1 station, but it takes a really long time. Level 2 charging requires less time, and then depending on where you go is going to require a special kind of adapter. And then when it comes to level 3 charging, which is fastest, the bulk of those chargers, at least in the current charging network that exists across the US, belong to Tesla and only work on Tesla vehicles. So part of what we wanted to figure out is not just, does charging infrastructure matter when it comes to potentially boosting Chevy's market share, but do certain kinds of infrastructure matter more than others? Next slide, please. So with all of that as background, we kind of necked this down to wanting to answer the following 3 questions. First, how does charging infrastructure affect EV sales and GM's market share specifically, especially in communities that are less affluent? Second, are there particular areas where that new structure is going to, that new infrastructure is going to benefit GM disproportionately? So in other words, does it matter where new infrastructure goes, or are there certain places where we'd expect infrastructure to not just help Chevy sell more cars, but to sell more cars faster than their rivals, and especially Tesla? And then finally, are there demographic indicators besides access to charging stations that offer new insight into GM's customer base? So we're working from the assumption that the lower price point for Chevy Bolts makes them more appealing in less affluent communities, but is that actually true? Or are there maybe additional factors that Chevy should know about and understand in order to respond to their customers more effectively? Next slide, please. And then this is how we proposed tackling that problem. So 4 goals. We wanted to do some kind of a sensitivity analysis to figure out what features in our data set matter most in terms of their effects on Chevy's share of the EV market. We wanted to do some kind of a segmentation analysis on communities to figure out if there are Chevy-friendly communities where new infrastructure might mean more. We wanted to see if we could develop a regression model that would allow us to predict Chevy sales and market share on the basis of infrastructure and demographics. And then finally, we wanted to pull together a dashboard and a mobile app that would allow us to visualize all of the information that we were pulling together and compiling. Next slide, please. So the data that we used for this project came from 3 primary sources. First is state-based vehicle registration data. 16 US states currently share their registration data for electric vehicles, including the number of EVs that they've registered per county and year by make. So that gives us kind of a way to get at that target variable of Chevy market share. The second data source comes from the Department of Energy, who maintains a record of every alternate fuel station across the US, and the type of station it is, who operates it, when it opened, how many chargers it has. So that's what gives us visibility on that charging infrastructure. And then third and finally, we pulled data from the Census Bureau and the American Community Survey to give us a view of community demographics on a targeted subset of the states and counties where we had that vehicle registration data. Next slide, please. So in the interest of time, I'm going to go ahead and skip past talking about what we did to clean and enhance these data sets. But I do think it's worth mentioning here that when we got to the point of starting to analyze some of this data, we had put in almost 200 different features associated with charging infrastructure. So we were looking at charging infrastructure by charging level, by access type, by network, by geographic density, by population density, and so on. And what we discovered is that none of those parsed out or more complex features were as good actually at predicting the number of Chevys on the road in any locality as just looking at the total number of chargers that exist in a county. In fact, we discovered that, and this might not be so surprising, that the number of EV chargers and the number of electric vehicles in a county are pretty strongly correlated with one another. So there's kind of an ecosystem that comes up where more charging infrastructure and more vehicles, they go hand in hand. And that's great, but in terms of our goals, it represents a little bit of a problem because while it's true for Chevy, it's also true for Chevy's competitors. So even though we see that infrastructure and Chevy sales tend to move in tandem, we don't see any kind of systematic advantages that Chevy gets over its competitors thanks to particular flavors of infrastructure within a locality. If expanding infrastructure helps Chevy sales, then it's helping Chevy's competitors too, which means that any help with market share is going to have to come from someplace else. Unfortunately, what we also discovered is once we got into that demographic data, even though Chevy's market share doesn't correlate strongly with any infrastructural features per se, it does correlate pretty strongly with some of the demographic characteristics of particular localities. Next slide, please. So again, getting past infrastructure and starting to dig into these demographics, what began to emerge was a kind of picture of Chevy's customer base as compared to the base of its biggest competitors. And this side-by-side comparison that we're showing here was developed by looking at the demographic variables where the magnitude and the direction of the correlation between a particular variable and Chevy's market share and Tesla's market share diverged most strongly. So in other words, the characteristics on the left had a strong positive correlation with Chevy market share and a strong negative correlation with Tesla market share. And then the characteristics on the right have exactly the opposite, a strong negative correlation with Chevy's market share and a strong positive correlation with Tesla's market share. And I'm not going to read through everything on this list, but what I think the list suggests is that Chevy EVs tend to play well in less affluent communities, whereas Tesla tends to do better in communities that have kind of the marks or the indicators of more affluent communities and neighborhoods. And so coming back to the hypothesis that we stated up front, I think between the last slide and this one, what we find is that we're on pretty solid ground. Chevy sells more cars in communities with charging infrastructure, and they tend to overperform their average market share in communities that are disadvantaged. So if the infrastructure bill expands a charging infrastructure into disadvantaged, underserved communities, that probably does put Chevy in a pretty good position to make progress toward their larger goal of increasing their market share. And with that, I will turn over to Raul, who's going to talk a little bit about how we segmented the communities that we had data on and got a better sense of which ones maybe gave a kind of systematic strategic advantage to Chevy versus its competitors.
Right. Thank you, Douglas. As Douglas actually mentioned, one of our primary focuses was just attaining a plethora of data that we could essentially use and analyze upon. And what we actually ended up with was just such a deep and rich contextual understanding of the EV market, something that I feel like we have not seen in prior work that anyone has actually performed. So we were really excited to get in and like do some exploratory analysis on that work that we on that data set that we had acquired. Some of the things that we worked on were EV infrastructure and EV registration correlations, which, surprise, surprise, there is strong correlation there. Another analysis that we performed was an income and EV registrant relationship. And we found that, yes, as incomes rose, there was a higher correlation with EV registration. But our biggest point of emphasis was with segmentation when in regards to analyzing our data sources. An aggregated data source, we wanted to see what the relationships are between our data points and our customers and how we could cluster those relationships together to get a full focused understanding of the potential Chevy consumer and also the competitive set. So what we ended up doing was performing a k-means cluster. We performed other clustering methods as well, but we found that k-means clustering was able to maneuver around the dynamics of such a rich and large data set that we collected. After employing the elbow method and other methodologies like silhouette coefficients, we've been able to find the ideal number of clusters for our data set, and that ended up being 5. And you can see the 5 clusters within the slide over here once the analysis was spit out. Cluster number 1 was active and outdoors segments. These people are the highest indexing cluster for the Chevy market share. They typically reside by nature. They like to get outside. They like to hike and do outdoorsy things. They're typically well educated and have low poverty areas around them. So these are people that, if you were to think geographically and regionally, they're primarily located in areas like Denver, Portland, places where people are very eco-conscious and wanting to get into nature. Cluster number 2 is Southern California residents. So this was primarily focused on regions and zip codes that were around the Southern California area, specifically around the coastline. These are commuter people, as you know, the stereotype of Southern California is people have to drive everywhere, and that was consistent with our analysis. Because there's a lot of diversity in the area, the neighborhoods tended to have a little bit more diversity as you went up and down the coastline, and they also tended to be a little bit more environmentally ambivalent. Cluster number 3 we found were people who had Southern ideals. They were located in states like Texas, Florida, and around that Gulf of Mexico area. These people are typically blue collar. They have a propensity towards high car and truck usage. Funny enough, they also have low gas usage. So that was a funny little tidbit about them that we were surprised to actually see. They also have the least access towards EV charging infrastructure. So when we were looking at the data, we saw that those regions were much more sparse in regards to having that type of, those type of resources available to them. Our 4th cluster was the working suburbs. These are satellite towns and cities outside of your major metropolitan hubs. You could think about this as suburbia. They are the 2nd highest indexing cluster for the Chevy market share. Heavy gas users as well, drive to work, drive to the grocery store, drive to see families and friends across large regions. And in these areas, they're typically economically diverse and also educationally diverse. Finally, our 5th cluster are tech and financial hubs. So again, a geographic assessment. These people typically skew towards, let's say, the Bay Area and the more affluent areas around New York City. They are affluent and they live in either metropolitan or the suburban posh communities. They're well educated and they're avid spenders. So these are essentially the people who are spending a lot of money, being very eco-conscious, and are are very, very high consumption data sets. So one of the things, this is really exciting data for us. One of the areas that we thought that this could be applicable was in marketing, creating lookalike models, creating assessments on future infrastructure projects, seeing how, monitoring legislation based off of regional propensities or demographic indicators. The applications are humongous. And we think that with this data and focusing in on these 5 core clusters, Chevy can actually raise their brand like exponentially, within the EV set. And now I'm going to pass it over to Swapna, who's going to talk about some of our modeling efforts.
Thank you, Rahul. Yeah, on the modeling side, one of the goals was to predict Chevy's electric vehicle market share and the electric vehicle charging stations. So we decided to use supervised modeling techniques. 2 supervised modeling techniques were explored. One was the ML modeling and the other one was the time series modeling. In ML modeling, 12 scenarios were explored with all features. As Rahul and Douglas mentioned, the data was rich with a lot of feature generation that really helped the modeling process. So it was done with all features. Then some important features were extracted, and then the modeling was done with and without PCA. So of all the various strategies, the top 3 strategies listed here below gave the best performance of accuracy of 92% plus, which was really awesome. To get this performance, feature scalarization, cross-validation, manual hyper-parameter tuning, and grid search were used. We also explored 12 ML models, such as the gradient boost, random forest, ensemble, vote regression, and so on. As far as the important features were concerned, they were retrieved using the XGBoost regressor model, where we used a combination of feature importance, gain, and cover metrics. So all these techniques and strategies really help to give a good performance for the ML modeling side. The next technique was the time series modeling. So the data was actually for the location, state, region, and county was converted into a time series format, and this resulted into 742 unique time series. So then back testing technique was used on each of these time series with 27 statistical models. And then using the performance metrics like absolute error, bias, and churn, one model per time series was, one model overall across all the time series was selected to avoid overfitting. So to predict the Chevy count, the best model was the Bayesian structural time series model, which gave pretty good results, as you can see below. Next slide, please. And so this resulted in a reasonable prediction with 95% confidence interval across the 742 time series. So we are showing you a sample here for the county of Seguche in Colorado State. For the charger count prediction, the model that got picked based on the performance results was the seasonal random walk drift model, and the performance of the model are as follows, as shown here. Since these models were selected, one model was selected across 742 time series. This is an overall result. So it is kind of up and down, the result here. Next slide, please. So this resulted in a reasonable prediction from Horizon 2 with a 95% confidence interval, again across 742 time series. In this predictions, the combination of the historical input data trend and model methodology resulted in a dip for the first horizon. So overall, the modeling techniques that were used were very interesting. And so to make it easier for the leadership to access the results from the clustering that Rahul spoke and for the modeling that was done, we decided to have it very easily accessible in a dashboard, as well as the web app for the a mobile app for the leadership to use. And so this is something that Farzad will be showing you. So I'll be handing this over to Farzad. Farzad?
Thank you, Swapna. As Swapna mentioned, we are using the web dashboard and mobile application to help Chevy leadership making data-driven decisions. So we've done, as a team, we've done research to choose most suitable platform and tools to develop and host the web and mobile applications. Based on the available resources, we decided to use Google Cloud Platform to host our analytical models. And for the web and mobile applications, we are using our Shiny and Shiny mobile packages for development, and we're hosting it on shiny.io server. The dashboard mainly serves as a tool to review the explanatory data analysis results, as well as displaying the predicted number of Chevy EV vehicles and charging stations for individual counties by time series analysis. And the mobile app is mainly focused on the forecasted number of Chevy EV vehicles and charging stations available for the users. One thing to consider is these apps are basically minimum viable products, and for proof of concept, there is an opportunity for more development and further enhancements in this area. With this background, we will do a live demo on the analytical dashboard. Okay, here's the electric vehicle dashboard that we developed for this project. On the left side, we will see the total number of chargers in the targeted states and counties, and as well as all electric vehicle registrations for those basically areas, and Chevrolet EV vehicle registrations. And we also show the number of counties affected, basically in the targeted, counties that we are using. We are able to just move along to see the data for different years. On the left side, we have the slider to basically do that. And, on the map itself, we see markers for the number of the charging stations per county. And we can basically also select to see the number of all EV vehicles, as well as the Chevy EV vehicles for individual counties. And if we zoom in and basically hover over a specific county, we will see the more detailed information, including the Chevy market share for that county. Moving to the next tab, which is the Chevrolet market share. We have basically the market share for individual counties as a waffle chart here. And again, we can basically see the changes over time, both on the basically line plot that we have here. We can see the trend, and we can basically move along. We will see the changes basically over time on the waffle chart as well. And we can do like a little animation here to see the changes over time. I'm gonna pause this and move to the next tab. The next tab is basically the time series analysis. And on the time series analysis tab, we will see the prediction for the Chevrolet vehicle count and charging stations for individual counties. And as Swapna mentioned, we are using the time series analysis to predict those numbers. On the left, we can change the state to see the results for specific counties and states. There we go. This is the Chevrolet vehicle count prediction, and we can move to a sub-tab, which is the charging station count prediction. On the data tab, we have the underlying data available for users to see, and if they need to do any further exploration, they can download the data as a CSV file and basically do their own explanatory data analysis. On the last tab here, it's basically about tab that we talk about our team and our mission. With that being said, I will hand it to Andy to go through the recommendations for this project.
Thank you, Farzad. So as you can see, with what all of our team has presented, we made a lot of great progress over the last 12 weeks, the last 10 weeks. And, really the thing that we want to leave you with today is that we're just getting started. There's a tremendous amount of work. As Farzad presented, we have a proof of concept going that really makes this information accessible to everyone. And, and with what modeling that Swapna put together, as well as the clustering work that Raul did, and the segmentation analysis that Raul put together. And finally, just having a really amazing set of insights that Douglas elicited. And that's where I think the recommendations stem from, is that we really see, bringing all of these together, that there is opportunity for Chevy to capitalize on the fact that infrastructure in the charging station infrastructure, the latest infrastructure bill is going to focus on disadvantaged communities. And so Chevy really should position themselves to follow that very closely, understand where charging infrastructure is going to be planned, and that they're going to capitalize on it because the focus is such on the disadvantaged communities. With the segmentation analysis and with the predictions that we've put together, we really think that Chevy can consolidate their brand loyalty, make sure that they capitalize on where they target and have had success in the past with those eco-conscientious working class folks, the people living in the areas that are very nature adjacent, and people understanding how their footprint matters, as well as the people that need to use this type of electric vehicle technology to make commuting easier, and to live in the suburbs, but perhaps commute into city centers. With that also said, though, we want to make sure that there's a long-term approach, recognizing that there is clearly a competing demographic, and there's much market capitalization that can occur with looking at how Tesla's been successful as the #1 leader in these areas that are, the Bay Area, highly affluent, highly educated, tech-oriented centers, and where the density of populations are much higher. We think there's a really big opportunity there, and we would encourage Chevy to focus on that. Those are our primary recommendations. Like I said, we're just getting started, and we've been really excited to share with you. And we want to thank you for your time today. So with that being said, we appreciate it and hope you have a great rest of your day.